Welcome to Mathematical Methods for Quantitative Finance. For this first video, I'm just going to do a quick overview of what you can expect during this course. So I'm your instructor, Chel Konis. First name rhymes with cello, so cello without the O. For evaluation for this course, this is something I can't really do very well in a massive setting. So what I've come up with are discussion questions. And so at the end of each video, there will be a discussion question. It should be something that if you've understood the video, that you'll be able to answer just within a few minutes. And then you're encouraged to share your solution on the forum. And so hopefully, sort of just organically, there will be some correct crowdsourced solutions. And additionally, there will be weekly homework assignments. And these will be more difficult problems. So the idea will be that you watch all of the videos for one particular week, and then you should be able to do the homework assignment. It should take you probably 3 or 4 hours, about the same amount of time as the videos take to watch. And then there will be a due date for these homework assignments. And after the due date, I will post solutions. And again, because it's a mathematics course, it's going to be something that's difficult for me to actually grade. So you'll be expected to just go through the solutions and grade yourself. And then one last thing I want to mention at the very beginning is Wolfram Alpha. This is a website. It's a lot like Google, except it's for asking and answering mathematics questions. A lot of what would normally be in a first-year calculus course or a first-year linear algebra course is some rote memorization. So they're just certain functions where you have to memorize this is the derivative of that. I don't really want to concentrate so much on just having you memorize things like this. So you can, and there are a lot of tools online now. So my favorite right now is Wolfram Alpha. And so for simple functions, for things like sine, cosine, logarithm, you can just ask Wolfram Alpha and just type into the search bar, what is the derivative of the logarithm? And it'll think for a couple seconds, and it'll give you the answer. So what the course is going to cover. So the numbers on the left here, these correspond to the weeks of the course. So this will be an 8-week course. The first week is going to be a review of limits and derivatives. The second week will be integration. So this is going to be essentially a 2-week review of what you would normally learn in a first-year calculus course. And then we'll move on to partial derivatives. And so a partial derivative is something you can take using the same techniques that we'll cover in week 1, but it's defined for a function of several variables. And then multiple integrals, week 4, is the same idea except for integration. So it's basically how you can make sense of integrals of functions that take several variables. And the reason these topics are sort of divided into two bunches, so we have 1 through 4 and then 5 through 8. What I'm really aiming for with the first 4 weeks is I want you to be able to take the derivatives of the Black-Scholes pricing formula. And since this is a math class, really what I'm going to be focusing on is the mathematics of this. So the Black-Scholes formula is just a function of many variables. And so if you understand the concepts that we're going to cover in these first 4 weeks, then you're going to be able to take the derivatives of the Black-Scholes formula. And these derivatives are something that's commonly known as the Greeks. The second set of lectures is going to be on linear algebra, Lagrange multipliers, and numerical methods. And the problem I'm looking at in this second set of the course is something called a minimum variance portfolio. And so what it'll turn out is when we look at linear algebra, we're really going to be concerning ourselves with solving systems of linear equations. Lagrange multipliers is going to give us the tools we need to calculate the minimum. So we want to find a portfolio of assets that has the minimum variance. And then it's going to turn out that when we use this Lagrange multiplier approach, it's going to give us a system of linear equations that need to be solved. So we'll have done that already in weeks 5 and 6. And then finally, in week 8, I'm going to start using something called the R environment for statistical computing. It's a software program for working with vectors and matrices, and also it's also a programming language. It's something very similar to MATLAB if you already have some experience with that. And we'll actually try and solve some problems using a computer to do that. So there's one recommended textbook for this course. It's a Primer for the Mathematics of Financial Engineering by Dan Stefanica. This is a much more general book than this course will be. So this book contains several mathematical topics as well as the financial applications of those topics. I'm going to just choose a few of the mathematical topics, and I'm going to focus much more on just the mathematics and not so much on the financial applications. And the idea being that after you do this course, you'll be a lot better prepared to go on to a course where they're going to focus more on the finance. And it'll be sort of like you sort of learn one thing first and then the other. And the idea being that will be a bit easier for you than trying to learn both the mathematics and the finance in tandem. And one thing that's nice about this course is there's also a solutions manual which has detailed solutions for all of the homework exercises in this book. And so I recommend if you can get your hands on the textbook that you also try and get the solutions manual, and then on your own time try and work through some of the exercises in the textbook, and then use the solutions manual to make sure that you're using the right approach and getting the right answer. And the last recommended book that I wanted to mention, so this is the first-year calculus book that they use at the University of Washington. And so that's why I've put it on this slide and I have a picture of it. But really, any first-year calculus book will be sufficient. And this one is over 1,000 pages long. And really what you're looking for is just sort of an encyclopedia of calculus, so that when you have questions, you have somewhere to go and look it up. So Calculus Early Transcendentals by James Stewart. Pretty much any edition would be sufficient, or any other first-year calculus book. But if you can get your hands on a book like that, that's going to be a valuable resource for doing some of the exercises in this class. Okay, so that's all I have for the introduction, and I hope you enjoy the rest of the course.